In this video, we're going to look at the binomial coefficients and how we can calculate those by hand. In the previous video, we looked at the binomial theorem, and in that video we introduced this notation NR in big brackets. And we said sometimes that's also called NCR, particularly in the calculator, that's the function we have to use to work them out. And remember, these matched up with the values in Pascal's triangle. So for example, if we were looking at 4, 3, which is the one over here, we're going to look at as an example, that meant it was in the fourth row of Pascal's triangle, and the third element in that row, remembering we started at 0. So the fourth row is 1, 4, 6, 4, 1. So that value there, 3, well, this is 0, this is 1, this is 2, this is 3, this is 4. We put the brackets round, that's 4, 0, 4, 1, 4, 2, 4, 3, and 4, 4. So we know 4, 3 is equal to 4. But we're going to look at how we can work this out, particularly for larger numbers, manually. And the way we do that is using this formula that we're given in the formula booklet, which is n exclamation mark over r exclamation mark n minus r exclamation mark. And the first thing we need to know is what that exclamation mark means. Well, that's the notation for factorial. So n factorial equals n times by n minus 1 times by n minus 2, and that keeps going all the way down to 1. We're going to have a look at that in a bit more detail in this first example. So 4, 3. Well, first of all, we just substitute the numbers in. That is 4 factorial over 3 factorial, 4 minus 3 factorial. So that's 4 factorial over 3 factorial, 1 factorial. Now 4 factorial means 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, and 1 factorial is just 1. And now what we can do is cancel elements on the top and the bottom. So the 1s don't matter anyway, the 2 cancels with the 2, the 3 with the 3, which just leaves us with 4. And we know 4 is the answer for this first one, because we saw that in Pascal's row. So let's look at the next one. 8 factorial over 5 factorial, 3 factorial. Notice that the two numbers on the bottom will always add up to the number on the top. Now we could write out the whole list, but actually we're going to notice a quick way. In this one up here, we had 4 times 3 times 2 times 1, but this bit, the 3 times 2 times 1, is the same as this bit. So that was actually 4 times 3 factorial. We're going to use that to make this a bit easier. 8 factorial is 8 times 7 times 6 times 5 factorial. That's over 5 factorial, 3 factorial. But now we have a 5 factorial on the bottom and on the top, so we can cancel them out. We don't need to work out 5 factorial. There's one on the top and bottom, so we can cancel them out. So we write up the numbers until we get to the biggest number that also appears on the bottom. Now we're going to write out the numbers. 8 times 7 times 6 over 3 factorials on the bottom, so it's 3 times 2 times 1. And again we can cancel. Well, 3 times 2 is 6, so they just cancel with 6, giving us 8 times 7, which is 56. So 8, 5 is 56. The last one is slightly bigger, but we're doing exactly the same way. it is 12, 7, so it's 12 factorial over 7 factorial and 5 factorial. We write out the numbers on the top until we get to 7 factorial, because we have 7 factorial on the bottom. So it's 12 times 11 times 10 times 9 times 8 and 7 factorial. On the bottom, 7 factorial, 5 factorial. The 7 factorials cancel out, and then we can write it out again, or we can just think, well, instead of writing 5 factorial on the bottom there, we can get rid of the exclamation mark and write it as 5 times 4 times 3 times 1. Now we can start cancelling. I'm going to cancel with the biggest number possible to make the number small. So the 5 can cancel with the 10, it leaves us with 2 on the top. The 4 and the 3 multiply to make 12, so they both cancel with the 12. And the 2 cancels with the, let's do that with the 8, to leave us with 4. So the sum we're left with is 11 times by 2 times by 4. That's a bit of a big sum to do, but we can do that. 11 times 9, let's do that first, is 99. Times 99 by 4, that's going to be 396, and times that by 2, we get 792 as the value of 12, 7. So this is how we can manually work out Pascal's elements, the elements of Pascal's triangle, using the binomial coefficient